Here we go. We have a question, largest divisible subset. We have given a set of distinct integers. We need to return the largest subset answer such that every pair of answer I and answer j of element in the subset satisfy these two conditions. So it means number I is a divisor of j or number j is a divisor of I. If there are multiple solutions, we can return any of them. So if the array is this, so this particular subset is the largest possible solution, or 1 3 is also acceptable. In this is the largest subset, right? So let's build the approach. So I have given this subset. I have given this array, and we need to figure out if the ith number and jth number is divisible or not, if I can include both the numbers in a particular subset, right? So what I will do, I will just check if this number is so let's say this is my number I and this all is my number j. So I will figure out is number j is a divisible of number I, and if yes, I need to also figure out the largest one, right? So our first step, our basic first step is to check if the jth number is a divisor of number I, right? So this array is unsorted. The first step is to sort this array. So we got 2 3 4 5, then 7 8, then 12 17 and 19. Yes, we got this array, and I will create a dp array. In this I will figure out that if this ith number is a value in for that my jth number is a divisor, right? So for this number there is no divisor, but this particular number I also need to figure out the length. So I will say the length of this particular subset or this value is only 1. So initially every value is 1, right? Yes. Then if I got this number, I need to check if previously we have seen a number that is a divisor of 3. No, we have not seen any number. Then if I got this number, we need to figure out if the previous number is a divisor of 4. So let's figure out 4 divisor 2. Yes, 2 is a divisor, right? So we got two numbers here. Yes. Then what I will do, I will also check for 3. Is 3 is a divisor? No. Then we got 5. 5 2 is a divisor? No. 5 3 is a divisor? No. 5 4 is a divisor? No. Then we got 7. Is 2 is a divisor? No. Is 3 is a divisor? No. Is 4 is a divisor? No. If 5 is a divisor? No. Then the next number is 8. Is 2 a divisor? Yes, 2 is a divisor. So we got 2, right? Because there are two values in the subset 2 and 8. Next, the number is 3. Is 3 a divisor? No. Is 4 a divisor? Yes, 4 is a divisor. So how many total numbers till 4? Till 4 we have two numbers, and if we include the number 8 in this place, I will got 3 numbers. So what I will do, I will just get 2 plus 1, right? The next number is 5. 5 is not a divisor of 8. Then 7 is also not a divisor of 8. The next number is 12. For 12, is 2 a divisor? Yes. So it means we got two numbers which is 2 and 12. Is 3 a divisor? Yes, 3 is also a divisor. So how many numbers till 3? Only 1. So till 12 we also got two numbers. It means I will include plus 1 and I will consider it. It will give me 2, but 2 is already there. Then is 4 a divisor? Yes. So for 4 till 4 we got two numbers, and till this we got 3 numbers, right? Then that's how this will work. But we also need to figure out that if like 4 is a divisor, and here we got the maximum value, right? So we need to figure out its previous position. what are its previous position, right? So we also need to make sure that we create a separate array, and which will include -1 initially, because it will denote the index. And let's start again. So our first number is 3. Is 2 a divisor of 3? No. Is 4? The next number is 4. Is 4? For 4 is 2 a divisor? Yes. So I will store 2 in this case. And for 4, the index we got is 0. Is 0, right? Yes. Then the next element is 5. For 5, if 2 is divisor, 3 a divisor, 4 a divisor? No. We got none divisor. For 7, do we get a divisor? No. Then the next number is 8. Is 2 a divisor? Yes. So I will first store the value 2 in this place. And as 2 a divisor of 8, so I will store the index on this position, right? The next number is 3. Is 3 a divisor? No. Is 4 a divisor? Yes. How many total values are there? There are total 2 values, and if I include 8 also, we got 3 values. So 3 is much bigger. So I will update this, and I will also update the index. I will store the index of 4. Index of 4 is 2, right? 0, 1, 2, 3, 5, 6, 7 and 8. For 4, for till index 5 we are sorted. The next index, the value is 12. For 12, is 2 a divisor? Yes. So I will first of all place 2 here, and I will also update the index. The index is 0. For 12, is 3 a divisor? Yes. But if I include 3, we still got value 2. So there is no point of updating our DP and previous. The next value is 4. Is 4 a divisor of 12? Yes. 4 a divisor. How many values till 4? 2. And if I include current value, we got 3 values, which is much bigger. So I will update here, and I will also update here. I will update with value 2. Then 5, 7 and 8 is not a divisor. For 17 we got no divisor. For 19 we got no divisors. So what is the largest subset? The largest subset can either be this starting at this index or starting at this index. We can include any subset, right? So if I include this, the previous index is 2, I will go to 2. Then I will include this. What is the previous index? Previous index is 0. I will go on this. The previous index is -1. So that's all. We will stop here. We will include 4, 2, 4 and 12 values, right? So this may be our answer. Or if I start from this, because this is also a valid answer, I will go to its previous index. Previous index is 2. Then previous index is 0. So I will go to 0. Previous index is -1. I will just stop here. And these are the values. That is my answer, right? So that's how this will work. Let's code this. I need DP of length n. I need previous of length n. I don't have n. For DP, it will contain initially 1, and for previous it will contain -1. Then I will start from this value, and j will start from till I. Is j a value that can divide I? If this is the case, then we can include this, but we need to also make sure that the value present on jth plus 1 must be greater than I. That is the only condition that needs to be checked. And I will just store the value, or I will also store the previous. It will contain j, right? And that's all. then I will contain the maximum I. Initially it is 0. If my dp of I is greater than maximum of I, maximum of I, it means a index. So index, right? So if this is the case, so max of I contains the index. If the if the ith value is greater than, then I will include that particular index, right? And that's all. The next step is to create our answer. While I will store previous of max I is not equal to -1. Till then we will iterate. I will just include the value present on max I index, and max I will change to previous of max I. Just return the answer. Let's run this. And we got memory limit exceeded. Okay. So max I, till max I is not equal to -1. Okay, wait a second. Let me debug this. I hope we are getting a valid answer, a valid DP. And our valid previous. And it is -1. Okay, so dp of j should not change, but it is changing. Previous of 0 should be minus. Previous of 0 should not change. Okay, I found the mistake. The mistake is previous. I need to change it to previous. And yes, this is the correct answer, and we just need to get our answer. Yes, so now we can remove this. Let's submit this, and in between let's talk about time and space complexity. So there's a mistake. So I missed the first step, which is to sort the array nums. Yes, now it should work. And in between let's talk about time and space complexity. So in this, our time complexity is n square, which is the maximum in between all these. So our time complexity is n square, and our space complexity is order of n only. And that's all. Thank you for watching this video.